if something is a function? Well, we also can evaluate functions by substituting in numbers. Whenever we have a function, we have an input and an output. And that's how functions work. They're that relationship. So I think of equations and functions as a rule. In this particular function, y equals 2x plus 3, the x's are our input and the y's are our output. So every x we put in is getting multiplied by 2, and then we're adding 3 to that. We can also replace y with f of x. If you see f of x, then we know that what we're dealing with is a function, because that is function notation. It doesn't have to be f of x. It could be g of x, h of x, r of x. It depends on what kind of function you're working with, and if we have multiple functions, we need to give them different names. Now, if it's y equals, that's an equation that could be a function, but it's not proven yet. You have to show that it's a function to use f of x. So let's look at this function. F of x is equal to 2x plus 3. Every x we put in, like I said, is our input. Every value we take out is our output, and that's our y value or our f of x value. That means every time we have an input and an output, it creates a point that is x, y, or x and f of x. So while f of x looks scary, it's really just different notation. It's the same idea as a y, it's just telling us what's happening. It's giving us a little more information. And we don't do any math with f of x. It's, again, just telling us what's happening. So if I'm evaluating something at 2, this function at 2, I will say f of 2. That doesn't mean I'm multiplying f by 2, it's just explaining what I should be doing. Let's try a practice. Here, I would like to find f of 3, and my function rule is that f of x is equal to 4x plus 1. So any x value I substitute in gives me an output that has been multiplied by 4 and added 1 to. So f of 3 would be equal to 4 times 3 plus 1. So when they give you a value to substitute in for x, you're replacing all of your x values with that number, or variable or expression, depending on what it is. So here we have the right side that we're going to simplify. 4 times 3 gives me 12 plus 1, and 12 plus 1 is 13. So f of 3 is equal to 13. This is a really useful tool when we start graphing, because this is giving us a point, a coordinate. This coordinate would be 3, 13, and that's a point we can actually graph. Remember, it's x and f of x, or x comma y. Sometimes we have two different values, and the f of x or g of x or h of x, that tells you which equation to use. So if I'm looking to find f of negative 2, well, I want to use f of x. So f of negative 2 would be equal to 7 times negative 2 minus 1. So I'm just using my function rule from up above to figure out a point. 7 times negative 2 is negative 14 minus 1 gives us negative 15. So we have found that using this function, there is a point negative 2, negative 15 that is somewhere on this function. If I need to find g of negative 4, I am using my g of x equation. So when I substitute, I have 1/2 times negative 4 plus 3. Well, half of 4 is 2, and half of negative 4 would be negative 2. So negative 2 plus 3 is equal to positive 1. So in this other function, we have a point negative 4, 1. We can also substitute in variables for variables. So if f of x is equal to 2x plus 3. Again, my function rule is that every x gets multiplied by 2 and we add 3 to that. I want to find f of a. Well, f of a means that I'm replacing all my x's with a's. So 2 parentheses a plus 3. Using order of operations, we want to try and simplify, but there is no simplifying that can be done. 2 times a is 2a plus 3. 2a and 3 are not like terms, so we can't combine them. So f of a is just equal to 2a plus 3. If I were asked to find f of a minus 1, then we're substituting in a minus 1 for all of our x's. So f of a minus 1 would be equal to 2 times a minus 1 plus 3. Remember, when we see a number outside of parentheses, I need to distribute. So 2 times a is 2a. 2 times negative 1 is minus 2, or negative 2. Bring down your positive 3. Now what is negative 2 plus 3? That's a positive 1. So f of a minus 1 is equal to 2a plus 1. And that's just helping us out if we're trying to evaluate something for a new number, and that new number we've had to take away 1 every time we use it. This can be our function rule for that.